All right, so let's talk about some fundamental identities of trig. Here we already know this one, that these are the reciprocal identity. If you have cosec theta, it's just 1 over sine theta. Sec theta is 1 over cos theta. Cot theta is 1 over tan theta, right? And tan theta is sine theta over cosine theta. And cot theta is cosine theta over sine theta. So we have the Pythagorean identity. These are, we have the sine squared theta plus cos squared theta equals to 1. Tan squared theta plus 1 equals to sec squared theta. And 1 plus cot squared theta is cosec squared theta. Now this, we can easily get it from here. If you remember this, from here we know that if you have r squared, it's going to be x squared plus what? Plus y squared. We know this from Pythagoras. But also, one thing we know from here is that I can find cosine theta. If you look for cosine theta from this place, it's going to be what? Cosine theta is x over r, right? And we know that sine theta is y over r. You know this. Okay, so what we can do is, if we look at this equation, let's start with this equation. Let me write it again. R squared is equals to x squared plus y squared. And we know r is not 0, right? So we can divide both sides by r squared. So if you divide this by r squared, divide by r squared, divide by r squared. So here will become 1. And this we can write it as x over r all squared. And this we can also write as y over r all squared. So here we'll have 1, it's equals to x over r is nothing but cosine. So this becomes cosine squared theta. And y over r is nothing but sine. So this becomes sine squared theta. So this is the first Pythagorean identity. And from here, you can create the remaining two. You can formulate the remaining Pythagoras identity. So for example, here, if we call this equation 1, let's say you divide both sides. Let's divide both sides by cos squared theta. So it means I will have 1 over cos squared theta is cos squared theta over cos squared theta plus sine squared theta over what? Cos squared theta, right? So, but what is 1 over cos squared theta? 1 over cos squared theta will give us sec squared theta, right? And here also, this will give us cos squared theta divided by cos squared theta is 1 plus sine squared theta over cos squared theta is tan squared theta. So this is the number 2. Then we can also get the third one. How can we get the third one? So here, remember here we divided equation 1. So we can say divide through, or we can say divide both sides of equation 1 by what? Divide both sides you can say divide through equation 1 by, now we will use what? We'll use sine squared theta. Okay, so to achieve that, it means you will have 1 over sine squared theta is equals to what? Cosine squared theta over sine squared theta plus sine squared theta over what? Sine squared theta. Now, 1 over this will give us cosec squared theta. And this will give us what? Cosec squared theta divided by sine squared theta is what? This is cot squared theta. And this is going to be plus 1. All right. So this is the third, what we call the Pythagorean's identity. So all you need to do is start with this diagram. This is a terminal. You have a point here. You have your R, you have your Y, you have your X. So you can always use your Pythagoras theorem to form this equation, right? So you have R squared is equals to X squared plus Y squared. But we know R is not equals to 0, so you can divide both sides by R squared. And then you have this one. Then you substitute X over R to be cosine theta and Y over R to be sine of theta. All right, now let's see how these identities are helpful. If you look at this question here, let's see how this will go. So this is tan 324. So you can see here, we know that 324 is in which quadrant? Is in the fourth quadrant. Now, since it's in the fourth quadrant, we're going to use a reference angle, right? But we know that tan is negative in the fourth quadrant. So this is going to be minus tan. And now we have to find the reference angle. What is the reference angle? This will be 360 minus what? 324. So it means that this is going to be minus tan of what? 360 minus 324. You see, it's going to be tan of 36, right? It's going to be tan of 36. So it means that minus tan of 36 is equals to x. So this is what we have from here. But now we want to find what is what? Cosec of 36. So we have to see what is the relationship. How can we relate all of this? All right, so here you see that we need to find a relationship now between cosec and what? Between cosec and tan. So, and if you look at all what we only have a relationship between cosec and what? And cotan, right? So what can we do? Here, if you look at this one, I can rewrite this as what? It means that tan of what? 36 is going to be minus x, right? See, it's going to be minus x. So from here, we can get cotan of 36. It's just going to be, what's just going to be minus the reciprocal, right? So it's just going to be minus 1 over x. Okay, so let's keep this. Now, we know there is a relationship between cosec and cotan. So this is going to be cosec, remember, cosec 36 is going to be square roots. It's going to be plus minus, right? Of cotan squared theta plus 1. I'm using this formula, and I'm using this number 3, you can see. But now, do we use plus or we use minus? We're going to use plus because, why? Because if you look at this angle, this is 36. 36 is in which quadrant? It's in the first quadrant. And in the first quadrant, cosec is what? Is positive, right? All right, so this is what we're going to have. Then now we will just use the fact that this is going to be the square root of, but what is called square theta? Now we're not using theta. Our theta is known. Our theta is 36. So in the place of theta here, I should use cot squared what? 36 plus 1. Now, what is the meaning of this? This means that what? But what is cotan? Cot 36, I already said is minus 1 over x. So this is going to be minus 1 over x all squared, then plus what? Plus 1. And then we can just simplify. This will be 1 over x squared plus 1, right? So here, this is now, we can simplify this to be x squared plus what? 1. No, this is going to be, we can rewrite this to be 1 plus what? X squared all over x squared, yes? And now we can take the roots. If you take the square root, if you separate the roots, you will just have 1 plus x squared over absolute value of x. See that? You just separate it up and down, right? But now, can we remove the absolute value? Let us check. If you see here, do we know if x is positive or x is negative? How do we know? We can see that here it is tan of what? Tan 324. This definitely is going to be what? It's going to be negative because remember, this 324 is what? Is in which quadrant? Is in the fourth quadrant. And in the fourth quadrant, we know tan is what? Is negative. So actually this x you're seeing here is less than 0. So it means that this is less than 0. This is going to be less than 0. Now, since it's less than 0, to remove the absolute value, you have to bring minus down. So this will just be root of 1 plus what? X squared. Then you have to put a minus out and just divide by x. All right. So this x is negative here. And that is why why did we use absolute value? We use absolute value because you have even roots and you have x squared, the denominator. Okay. Cool. So let's solve another interesting problem here. So this is also going to be similar stuff. Now, look at this one. This is sec, but this is 9 pi over 5. So 9 pi over 5 is in which quadrant? This definitely is between 3 is less than 2 pi. So we don't need to look for what? We don't need to look for coterminal. We just need to know which quadrant is it, and we use the reference angle theorem. So here, 9 pi over 5, right? Because 9 divided by this, you can see that this is going to be like in the fourth quadrant. Or you can just, you can convert it towards, right? Divide by pi. So this will go with this. And 5 here is what? 5 here is 3, right? So we have around 36, right? Okay. So what can we do? Now we will see which quadrant are we? So you can see that what if you do 9 times what? 9 times 36. 9 times 36 will have, it's going to be a number around 3 something, right? So this is going to be around 324, which is in the fourth quadrant. And another way you can know that it's in the fourth quadrant without converting it to degree is simply you use this, right? Remember, this is what? This is 0, this is pi over 2, this is pi, and this is 3 pi over 2. So if you compare 9 over 5 and 3 over 2, so you see that what? 9 over 5 is greater than 3 pi over 2. 9 over 5 is greater than 3 over 2, so it's going to be somewhere here. So we are actually in the fourth quadrant. Now, since we're in the fourth quadrant, we know sec is positive in the fourth quadrant. So it means we just need to use the reference angle, which is going to be 2 pi minus 9, right? And this is E equals to X. So what would this give us? This is just going to give us sec pi over 5 equals to what? Equals to X, right? So here, what did we use? We use reference angle, reference angle. Okay, so this is reference angle. All right, so what next can we do here? But we're looking for tan, but remember there is a relationship between tan and sec. If you go back to these identities, that is the Pythagorean identities, you will see that we have what? For the Pythagorean identity, we also have what? Sec squared theta is what? Is 1 plus tan squared what? 1 plus tan squared theta is equals to sec squared theta. So we can use that, right? So this is what I'm talking about here. This one. Sec squared theta is 1 plus tan squared theta. So that we can use because we already have sec, right? So once we have sec, we can find tan. So tan is going to be, is going to be plus minus, right? Root of what? Let me write it again. This is the formula. Sec squared theta is 1 plus what? Tan squared theta. So if you are looking for tan squared theta, it's just going to be sec squared theta minus 1. But here also we need the positive 1. Why? Because this is pi over 5. Pi over 5 is in the first quadrant, so its tan is going to be positive. Now we can use the sec now. So we're not going to use theta itself, but we're going to use sec squared pi over 5. And this is minus 1. Now this is going to be roots. But what is sec squared? But we know that sec pi over 5 is x. So this is just going to be x squared minus 1. Yes, so this is just our answer here. X squared minus 1. All right. And the answer is C. So this means that from here you can see that tan squared theta is sec squared theta minus 1. So this means that tan theta is going to be the root of sec squared theta minus 1, plus minus. Okay. All right. Now we talk about co-function identity. So co-function identity is also very important. There is always a co-function identity between sine and cosine. So if you have sine 90 minus theta is the same thing as what? Cosine of theta. And also, there is also a co-function identity between tan and cotan. Tan 90 minus theta is the same thing as cotan theta. So also here, there is a co-function identity between sec and what? Cosec. So it means that, for example, if you have sec 45, it's going to be the same thing as what? Cosec 45, right? And if you have sec 20, it's the same thing as cosec 90 minus 20 is 70. So all these are what we call co-function identities. All right. So here, what do we want here? Look, this is tan what? Tan 71 is equals to B. But what is tan 70? There is a co-function identity between tan and cotan, right? So it means that this is the same thing as cotan. Let me use the red pen here. Pink one. This is the same thing as cotan of what's 90 minus 71 is equals to B. Yes. What are we using now? We are using this co-function identity between cotan. So if you have tan, you can always change it to what? To cotan. It's okay? Just 90 minus. So this is what we're using. We're actually using this one. So we have tan theta. You can change it to cotan 90 minus theta. And if you do this, this will just give us what? Cotan 19. So it means cotan 19 is equals to B, right? Cotan 19 is equals to B, okay? But what do we know? We know that there is a relationship between cotan and what? And cosec, right? And don't forget that we have that what? If you have cosec squared theta, it's nothing but what? 1 plus cotan squared, think cotan squared theta, right? Is it? Or the other way around. Yes, so let's confirm this. Pythagoras. Okay, so this is what we have. It's 1 plus cotan is what? Is cosec squared. So that is what we will use there. All right, so here it means that cotan, so what is cosec squared? If you look at this, it means that I can remove this cosec squared, yes. If I remove cosec squared 19, based on this formula, I can put 1 plus what? Cotan squared, then what's 19 degree. But we still have plus 1, right? Okay. Now, what is this one? Let me keep this in circle here. So this means that this will become cotan squared 19 plus 2, right? Because 1 plus 1. But what is cotan? Cotan 19 is B, so this is just B squared plus what? Plus 2. All right, so this is this is this is this. B squared plus 2. So this is an application of co-function identity. All right, so thank you for watching. In the next video, it will be the exercises for 5.3.